Welcome viewers. In this video we will see the types of algebraic function available in sets, function and relation, one of the topic in mathematics. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic types of algebraic function. The first one is identity function, a function that associated each real number itself. So the identity function is the function that associated each real number itself. Absolute value function, the function f of x defined by f of x equal to modulus x, that is equal to x for x greater than or equal to 0, minus x for x less than equal to 0, right? So the absolute value function is, the function is defined as that is equal to modulus of x. The x value is, it will be equal to x in case x greater than or equal to 0, minus x in case of x less than 0, right? So greater than or equal to 0 means x, less than 0 means minus x. That is called a absolute value function. Constant function, a function f of x defined by the f of x equal to k, where k is the real number. That is, if the function is equal to k, where k is the real number, that is called a constant function. Then greatest integer function. Greatest integer function, the function f such that r from r, f from r to r defined by f of x equal to x for all x related to r. So that is the greatest integer function. The function f such that r goes to r defined by f of x equal to x for all x belongs to r. Then signum function, the function f defined by f of x equal to modulus of x by x for the case x not equal to 0. The function f of x equal to 0 in case x equal to 0, right? For x not equal to 0, it is value is modulus x by x. X equal to 0 means the value is 0. That is called signum function. Then polynomial function. Then another two functions are there. Polynomial function, the function f such that r from r defined by f of x equal to a naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2, it goes up to a power n, an, where a naught, a1, an are constant. So this is called a polynomial function. There are polynomial powers are available. So that is called a polynomial function. A naught, a1, a2 are constant. The power is x power n, x power n minus 1, x power n minus 2, like that it will go. Finally we have only an. This is called a polynomial function. Relational function, the function f from r to r defined by f of x equal to p of x divided by q of x, where q of x not equal to 0, right? And p of x, q of x are called polynomial, right? Relational function, there is a relation. We are having the two relation, p of x divided by q of x. These two are polynomials. These two are polynomials. So that we are finding the relation between these two, the ratio between p of x by q of x. The important thing is q of x not equal to 0, right? So that is called a relational function. These two are polynomial. So in this video we discuss the types of algebraic functions. First one is identity function. Identity function means it is related to real number. Then absolute value function. Absolute value means mod of x. Is x is less than 0 mean the value is minus x. X is greater than 0 mean the value is x. Then constant function, f of x equal to k. This is k is the real number. There is no function, it is constant. Greater integer function, that is f of x equal to x for all x related to r. Then signum function, f of x equal to modulus of x by x for x not equal to 0 and equal to 0 in case of x equal to 0. Then polynomial function, there is a polynomial powers are available. So that is called a polynomial function. These are all constant. Then relational function, we are finding the ratio between p of x and q of x. So that is called a relational function. P of x and Q of x are polynomial. Then Q of x not equal to 0. If it is equal to 0, the total value becomes 0. The condition, it should not equal to 0. Right? Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we will see the algebra of function. The topic available in sets, relation and function. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. First you will see the addition. If function such that d1 relates r and function g such that d2 relates r, then their sum f plus g such that d1 intersect d2 relates r. So such that f plus g of x equal to f of x plus g of x. For all the x implies d1 intersection d2. So the name is addition. So the function f is available, relates r, d1 relates r. Function g is available, d2 relates r. While adding two function f plus g, we have d1 intersection d2 relates r. Right? So the f d1 relates r, g d2 relates r. While adding d1 intersection d2 relates r. So that f plus g of x, we can add f plus g of x can be written as f of x plus g of x. So for all x implies d1 intersection d2, right? So the two functions available f plus g, while adding it will give f of x plus g of x. So that is the meaning. Similarly, subtraction. If function f such that d1 relates r and function g such that d2 relates r, then their difference f minus g, that is such that d1 intersects d2 relates r. So that such that we can write f minus g of x equal to f of x minus g of x. For all x implies d1 intersection d2. So it is very similar to subtraction, very similar to addition. Addition we are adding. While adding two functions, we can write it separately, f of x plus g of x. Similarly, while subtracting, we can write f of x minus g of x. For all the x implies d1 intersection d2. Now we'll go to the product. Same thing. If function f such that d1 relates r and function g such that d2 relates r, then their product f into g such that d1 intersects d2 related to r. In that case, such that f dot g of x can be written as f of x into g of x. For all x implies d1 intersection d2, right? So this is about product. f1 we have f2, while multiplying these two we can write f of x into g of x. Similarly, we have the quotient. If function f such that d1 relates to r and function g such that d2 relates r, then their quotient f divided by q such that d1 intersects d2 is can be written as set of x such that g of x equal to 0 relates r, such that f divided by g of x equal to f of x divided by g of x, such that for all x implies d1 intersects d2, that is x, the set of x such that g of x equal to 0. So this is the quotient. Same thing, d1 function d1 relates r, g function g d2 relates r. So that f by q, d intersects d2, that is written as set of x, g of x equal to 0. We are taking g of x equal to 0, such that f divided by g of x equal to f of x divided by g of x, such that x implies d1 intersects d2, that is set of x, g of x equal to 0. That is related to the quotient. Then we'll have one more, then composition of function. One more term is available. If function f such that A implies B and function G such that B relates C. A relates B, B relates C, then the function f A relates to C defined by f of x equal to g of f of x for all x implies A. Right? This is a composition of function. The function A is function f is A related to B. Function G is B related to C. Function G for GOF A related to C is defined as g of f of x for all x implies A. Right? So in this video we discuss the algebra of function, addition, subtraction, product, quotient and composition of function. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Viewers, in this video we will see the kind of function, not one of the topic available in sets, function and relation. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, kinds of function. The first type is 1, 1. A function f such that A relates to B is said to be a 1, 1 function, that is injection. If different elements of A have different images in B, that is called 1, 1 function, right? A function f is available such that A relates B is said to be 1, 1 function, injection, right? A relates to B is available in function B. If different elements of A have different images in B, that is called a 1, 1 function. Then onto function, onto, right? A function f such that A relates to B is said to be an onto, that is surjunction function. If every elements of B is the image of the same elements of A, right? The previous one different images, here same. Every elements of B is the image of the same elements of A is called a onto function. That is called surjunction. Previously injection, one is injection, onto is surjunction. Then we have bijunction is available. Another 2 more functions are available, bijunction. Now we will see what is the bijunction. A function f such that A relates B is a bijunction if 1, 1 as well as onto. A function satisfy 1, 1 as well as onto, that is called a bijunction function, right? We already discussed what is 1, 1 function, what is onto function. A function satisfy both 1, 1 function and onto function is called a bijunction function. Then inverse of a function. Let the function f such that A relates to B be a bijunction. Then G, function G such that B relates to A, whose associate each element y implies B to A. Unique elements x relates A such that g of y equal to x is called a inverse of function f, and it is denoted by f dash, right? It's very simple. The inverse function is, first consider the function f, that is A relates to B. Another function G, B relates to A. In that associate each elements y implies B to a unique element of x implies A, right? The A relates x, B relates y, such that g of y equal to x, right? F of x, g of y equal to x. So this is the inverse function. It's called a inverse function f, and it is denoted by f dash, right? So in this video we discuss kind of function, 1, 1 function, that is injection function, different images, different element having different images. Onto function called surjunction, that is same element having same image, it's called a surjunction. If you satisfy both injection and surjunction, one to one and on to, then it is called a bijunction function. The third type. Fourth one is inverse. F of the function f is available, a relates to b, g is available, b relates to a. So that y, we are referring y, implies b to a. So that x implies a. Right? So that we have the inverse function, g of y equal to x for a inverse function of f, that is also denoted by f dash. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we will see the formula to remember for sets, relation and function. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Important formula to be remembered. First one is De Morgan's law. That is the sets, relation and function. De Morgan's law. First one is A union B dash equal to A dash intersect B dash. Right? The De Morgan's theorem. Here union means here intersection. Here whole bar available, here bar available individually. A union B dash equal to A dash intersect B dash. Similarly, A intersect B equal to A dash union B dash. Right? Both are differ. Here intersect mean union. Here union mean intersect. A divided by B union C equal to A divided by B intersect B divided by A divided by C. Right? That is nothing but A divided by B, A divided by C. Here union, here intersect. Right? A divided by B union C is nothing but A divided by B intersect A divided by C. Right? Then A divided by B intersect C is nothing but A divided by B union A divided by C. Right? So it is very simple. Here union means intersect. Intersect means union. Union means intersect. Intersect means union. Right? Like that we have 4 De Morgan's theorem available. Using that we can solve the problem. Then reflective. A relates A, small a, for all A belongs to capital A. So this is a subset, this is a main set. Right? So A relates A for all A, small a, subset relates to the main set. Right? Then we'll go to the remaining. Symmetric. Next one is the symmetry. A relates B implies B relates A for all A comma B belongs to A. Right? Symmetric means A relates to B, B relates to A. Right? That's a symmetry. A to B, B to A also same. For all A to B belongs to capital A. Right? These two are subset, that is belongs to the main set A. Then transitive. A relates B, comma B relates C implies A relates C for all A, B, C belongs to capital A, belongs to the main set. Right? So here A to B, B to C. Here A to C. Right? So the transitive. This transitive A to B, B to C implies A to C. Right? Here if we are going from A to B, B to C. So that A to C also available. For all A, B, C belongs to the main function, main set A. Then anti-symmetric. We already discussed symmetric. Now anti-symmetric. A relates B and B relates A such that implies A equal to B for all A comma B belongs to capital A. Right? So this is a anti-symmetric. Right? A relates B and B relates A implies A equal to B. That is A difference. A symmetric B equal to A divided by B union B divided by A. That is the meaning of anti-symmetric. Right? A symmetric B equal to A divided by B union B divided by A. Right? We have another 2 more functions available. We'll see that. 1-1 function. 1-1 function. If function f such that A relates to A A goes to A. Then function f of x1 equal to function f of x2 implies x1 equal to x2 for all x1 x2 belongs to main set A, right? That is a one-to-one function. The function f is available, A implies to A. Then f of x1 equal to f of x2 implies x1 equal to x2 for all x1 x2 belongs to A. Then onto function, codomain equal to range. If a set has n elements, then the total number of subset is 2 to the power n. So onto function is, it will give the n elements available in the set means the subset having total number of subset will be 2 to the power n, right? So in this video we discuss the important formula for sets relation function. First discuss the De Morgan's theorem. There are 4 laws available. De Morgan's theorem. A union B dash equal to A dash intersect B dash. A intersect B equal to A dash union B dash. A divided by B union C means A divided by B intersect A divided by C. A divided by B intersect C means A divided by B union A divided by C. Right? This side union means that side intersect. Then reflective theorem, reflective, symmetric, transitive, antisymmetric, one-to-one function and onto function. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the properties of set operation. One of the topic available in sets, relation and function. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic, property of set operation. First one is commutative. In that two division available. First division, A union B equal to B union A, right? A union B, if you take, that is equal to B union A also. Similarly, A intersect B is equal to B intersect A. So both are equal. Then associative, A union B of union C. A union B of union C equal to A union of B union C. Right? Here A and B is combined together. Here B and C is combined together. Both are equal. A union B of union C equal to A union of B union C. Similarly, A intersect B of intersect C equal to A intersect of B intersect C. Right? Here AB combined, here BC combined. Right? So both the terms are equal. If you A intersect B, that is intersect C is equal to A intersect, that is intersect with B intersect C also. Both are equal. Then distributive. Next one is the distributive property. A union of B intersect C. So previously we have only all are union. Here all are intersect. Here both are combined. A union of B intersect C equal to A union B intersect A union C, right? So that is written like that. A union B intersect A union C. That is the distributive, first distributive property. A intersect of B union C is equal to A intersect B union A intersect C. That is A intersect B union A intersect C, right? The A is first combined with B and A is combined with C with intersect. In between we have union. So that is called a distributive law. Next one is the identity. The next property is identity. A union null equal to A, right? If set A union null set means not having any element. So the set A is combined with null set means it will give A only. A intersect U null set equal to A only, right? Then idempotent, that is A union A equal to A. While combining A with A, it will give A only. A intersect A also A, right? Both are equal. Then absorption, A union of A intersect B equal to A, right? While A union A intersect B, we will get only again A only. Similarly, A intersect of A union B, that will give also A only. So this property we can use while solving the problem. A union B intersect B will give A only. A intersect A union B also will give A only. Then we have De Morgan's theorem. The important thing is we have the De Morgan's theorem. A union B dash equal to A dash intersect B dash. Important thing is here union means here intersect. Here dash available. Entirely dash available. Here individually dash available. A minus B union C is equal to A minus B intersect A minus C. Right? You can write that A minus B you intersect A minus C. Right? Not like a normal subtraction. A minus B. Then A minus C. Here union means here intersect. A intersect B dash equal to A dash union B dash. Right? Here intersect means here union. The dash available entirely, here dash available individually. Similarly, A minus B intersect C. Here union is there, here intersect. What is that? A minus B. Here intersect means union. Then A minus C. Right? So A minus B union A minus C. Right? So the important thing here union means intersect. Here union means intersect. Here intersect means union. Here intersect means union. Right? Like that you can remember. On symmetric difference, A symmetric difference of B is equal to B symmetric difference of A. Right? So both are equal. A symmetric difference of B of symmetric difference of C equal to A symmetric difference of B symmetric difference C. Here A and B combined. Here B and C combined. Both are equal. A intersect B symmetric C can be written as A intersect B symmetric difference of A intersect C. Very simple. A and B is combined here. And A and C is combined here. Symmetric difference. Here intersect means here also intersect. So A intersect B. A intersect C with symmetric difference. That is the important formula. We'll go for some more properties. The next one is the on empty set and universal set. Pi dash equal to U. Similarly, U dash equal to pi. This is the pi means empty set. Pi dash means universal set. That is equal to U. U means universal set. But U dash is the empty set. That is equal to pi. Very simple. A union A dash equal to U. A means the set. A dash means other than set. So while combining both, you will get universal set. Then A intersect A dash equal to pi. A is the set. A dash means A, nothing. The other than A dash, other than A. So while combining two, we will get pi only. Null set. A union universal set equal to U. A intersect universal set equal to A. Right? So the U means universal set. Pi means null set. Right? So pi is the null set. While taking pi dash, automatically we will get universal set. U is universal set containing all the elements. U dash means nothing. Pi is null set. So the set A is A union A dash. A means the elements in the A. A dash means other than the elements. So while combining both, we will get all the universal elements. A intersect A dash means nothing will be there. The A is the set of elements. A dash means other than A. So the common, there is no common. So null set. A union universal set. So universal set contain all the elements. So automatically the result will be universal set. A intersect universal element is a A. Universal set contain all the elements. A contain the elements of A. So the common is A only. Right. Next one is the on cardinality. Cardinality, the next property. We'll see that. The first one, for any two finite sets A and B, we can write n of A union B equal to n of A plus n of B minus n of A intersect B. So this will give the number of elements. These three will give the number of elements. Number of elements in A union B means A number of n of A plus n of B minus n of A intersect B. If A and B are disjoint finite set, then this is a finite set. This is a disjoint finite set. A union B equal to n of A union B equal to n of A plus n of B. Finite set means we are subtracting. For disjoint, we are not subtracting. N of A plus n of B. For any three finite set, A, B, C. So these two are two set. This is a three set. N of A union B union C equal to n of A plus n of B plus n of C minus n of A intersect B minus n of A intersect C minus A intersect n of B intersect C plus n of A intersect B intersect C. Right? So first the n of A, B, C is available. Then subtract the intersect AB, AC, BC. Then add intersect of ABC. So this is the related to the three sets. Right? So in this video we discuss about the properties available in the set that can be used for solving the problem. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.